Okay, for 11b, this is a different type of problem than 11a. For 11a, we did that procedure where we found the period and we had a scale factor. For this one, because there's a 1 in front of the x, that means the period is not changing, so we don't have to do that same process on this one. What we noticed is we got this problem will have either a plus or a minus on the end. That's the other type of variation that I would give you. It could be a tangent also with a plus or minus in it. This particular one happens to be a cotangent, but I could give you a tangent one as well. So you want to make sure you know how to do either one of those if I have a number being added or subtracted to this one. Now we want to start with the key points for cotangent. And so that one's going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. These would be the key points for a cotangent graph. Okay, so notice they are different from the regular key points for tangent graphs. These are different. These are the ones we're starting with. What you will do, if you have a problem like this that has an x plus or minus a number, you're going to do the opposite operation of the sign that you see here with these key points. So in other words, in the problem itself, I have x plus pi over 3. I'm going to do the opposite operation and I'm going to subtract pi over 3. In fact, I'm going to do that to every single key point. What this is really doing is it's a type of transformation. So transformations you would have seen in pre-calculus. So for this one, if we have plus pi over 3, it really means you're shifting the entire graph to the left. So that's why I'm actually subtracting these, because subtracting that will push the graph over this way to the left. So I'm going to do that now for all these and get the results. So 0 minus negative pi over 3, that's negative pi over 3. For all the other ones, if you want to do these in your calculator, you can. You can just ignore the pi's and just do 1/2 minus 1/3 and so forth to get those key points there. You're going to get pi over 6 if you get common denominators. Pi divided by, this would be like 3 pi over 3 minus pi over 3, 2 pi over 3 you would get here. And you're just going to do the same thing all the way across. I'll just give you the results that you'll get here, 7 pi over 6 and 5 pi over 3. So by doing that, we've shifted everything over to the left, and these would be now your new key points. Like the tangent graph, the first one, middle one, and the last one are always the ones that are going to have your vertical asymptotes. So we're going to keep that in mind when we do this. Okay, so now that you have that, let me erase this. And so now we're going to get the line there that we'll graph it with. So here we go, we got that. Your axis line will be somewhere around there in between. It's not a key point, so it's not really a big concern to us, but we will have that on the graph. And then we have these other ones here. So these are all your 5 key points. I mentioned that the first one, the middle one, and the last one are the ones that are going to have vertical asymptotes. The ones in between here, pi over 6 and 7 pi over 6, are going to be the x-intercepts for the graph. Now cotangent, the normal graph for cotangent actually will look like that. And there's no negatives or anything on this one, which means that the cotangent graph will just look like that one. Okay, again, if I had a negative in front of it, I'd be flipping it over, but don't need to do that in this one because there's no negative in front. So the graph should just look like that one. The graph will follow this vertical asymptote, it'll curve, hit the x-intercept, go down and look something like this, and the other one is going to do the same thing. Okay, it looks like that. So this would be your completed graph. It does say on the test to draw 2 periods, but as long as you use these key points, the original key points from the original cotangent graph, that's automatically 2 periods anyway.